Okay, ladies and gentlemen, I think we'll make a start. They didn't get the chairs to synchronise watches, so I can't guarantee we're exactly in sync with the other sessions. My name is PJ Stephenson. I'm with IUCN in Lyon in Switzerland, and I'll be your chair for this session this morning on conservation science, anthropogenic threats and solutions. So now's the time to run if you're in the wrong session. And we're going to start with a presentation by Paul Lintott from the University of Exeter. Over to you.
Okay, I'm going to be presenting results from the National Bats and Wind Turbines project, and in particular I'll be looking at the effectiveness of ecological impact assessments at predicting risk to bat casualties at wind farms. So before I start, I'd like to thank the funders, in particular NERC, who funded my postdoc, and also DEFRA, who funded the overall project. Also, the field staff who worked on the project, in particular Suzanne Richardson, who was the PhD student who collected the information and is also first co-author on the paper that I'm presenting. Just so that you're aware, I'm presenting one paper which we got from the project. Fiona Matthews is going to be presenting an overview of the overall project on Wednesday the 14th December in the Ecology and Society session, room 13 at 10:45, so it might be worth going along to that as well if you're interested. So I think it'd be preaching to converted to go on about why we should be supporting wind turbines and renewable energy. Obviously, renewable energy has lots of positive connotations for biodiversity and ecology. However, there are negative aspects of renewable energy and wind farms. This can include light pollution, habitat disturbance, habitat modification, habitat loss from not only construction of wind turbines, but the infrastructure which surrounds them, and also bird and bat collisions. So one of the main ways to preempt this and trying to lessen the environmental impact is to conduct environmental impact assessments. Now, these are systematic processes to identify, predict, and evaluate the environmental effects of proposed actions and projects. So for bats, you might go along to the site before the turbines were constructed and do some bat activity surveys. So you could look at things such as habitat suitability. We know that bats prefer woodland habitats, riparian habitats, so are these habitats in the surrounding landscape? We might put some bat detectors out and look at foraging activity, or see if there's any commuting rates. This is particularly important for species such as Nathesius pipistrelle, which are migrants, and we can see if wind turbines are going to get in the way of their migratory routes. Once you've done that, you can come up with a perceived risk. How likely are bat populations in the local area likely to be impacted by the turbines? So you can have quite a low risk and no action may be required. Maybe you can just build the turbines and we're happy with that. Possibly have some moderate risk, in which case mitigation may be required. This could include building the turbines at least 100 metres away from the nearest linear feature, which is the mitigation strategy proposed at the minute. Alternatively, if you've got a very high risk to local bat populations, then maybe planning permission will be denied. So we were really interested in asking the question, are environmental impact assessments able to predict the risk to bats? How do we maximise the benefits of renewable energy while minimising the risk to wildlife populations? So to do this, we conducted carcass searches around the UK. I can't show you the exact locations of where we surveyed because all the sites are confidential. However, this map hopefully shows that we managed to cover a wide range of the UK. So your map on your left shows where we surveyed, with the lighter areas indicating increased surveying effort. The map on the right shows wind farms across the UK, again lighter areas showing where there's more wind turbines. So you can see they match quite nicely, so we put more surveying effort into areas where there were more wind turbines. The National Bats and Wind Turbines project surveyed 46 wind farms in total. However, we were only able to obtain 29 environmental impact assessments. So for this talk in itself, I'll only be looking at the 29 wind farms where we collected the environmental impact assessments as well. Again, Fiona will be presenting the results from all 46 on Wednesday. So we looked at the environmental impact assessments, looked at the survey methodology of them, how they assessed if bats were present within the site, how much activity was within the site, and if they perceived a risk to bat populations. We also looked if any mitigation strategies were proposed. And looking at the EIAs, there's quite a range of outcomes. So these are direct quotes from the EIAs themselves. So we have quite a lot of sites which said there'd be no risk whatsoever. This were quotes such as, there is no risk to protected species, or there will be minimal effect of a protected species. Alternatively, there were some which perceived at least some level of risk. And we can think of this as a sliding scale from quite low potential risk to quite high potential risk. At the low end of the scale, we've got quotes such as, bats not active within the study area, but surveys confirm presence in adjacent areas. So you know they're around, but maybe they're not going to be impacted by the turbines themselves. Moving on, you can look at results showed that 12 species used the site. However, the impact was not considered significant. And then moving on to places where mitigation was considered. Here, they found high impact on bats due to loss of hedgerow, foraging and commuting habitat, and mitigation was undertaken. So here we've got a sliding scale of perceived risk. So those are the EIAs, and then we undertook acoustic and carcass searches at the sites. So within wind farm site, we surveyed each site for a month and surveyed 6 turbines within the site. Because we use search dogs who are much more effective than humans at finding bats on the ground, and we looked at, rather than looking at the raw data, we calculated an estimated casualty rate taking into account searcher efficiency, because the dogs weren't perfect at finding the bats. And we also looked at predator removal. You've got beetles removing the bats, foxes removing the bats, and so we added this to come up with an estimated casualty rate, which was a lot more reliable than just using the raw data that we found. So on to the results. Of the EIAs that we looked at, 18 of these sites concluded that assessment was not required, or there's no significant effect of the proposed wind turbines on bat populations. So they might have gone out, just looked at the habitat and thought, nope, that's fine. Or they might have undertaken some bat surveys, not recorded any bats. No significant effect was there. However, looking at the results of our carcass surveys, we estimate that 9 of the 18 sites had casualties, and this ranged from 1 to 64 bats per month being killed. So this is quite significant. And these were the sites where there was no perceived risk at all. So to show this graphically, on the y-axis here, we have estimated bat casualties per site. So again, how many bats have been killed per month. And on the bottom 2 bars, you've got no perceived risk. So these are sites, again, where nothing was thought to be impacting bats. And approximately 6 bats a month were being killed at these sites. Or areas where there were some perceived risk, there were approximately 8 bats being killed a month. So we did a Mann-Whitney test on this data, and it wasn't significant. In other words, perception of risk is not related to bat casualties. So it doesn't seem obvious, that intuitive, that you can go along and try and predict what is happening to bat populations. Secondly, in terms of acoustic surveys, we found that 16 of the 18 sites where bats weren't recorded previously had activity present. And this ranged from having 1 pass per night to an average of 236 passes per night. So once the turbines have been constructed, there seems to be quite a lot of activity going on. Secondly, we looked at the sites which were ranked by perceived risk. So this is, again, this sliding scale from low perceived risk to high perceived risk. And here on the x-axis, we have sites ranked by pre-construction risk, with the higher number being the sites which were perceived to be very high risk, and the left-hand side of the scale being the sites which were thought to be moderately okay. And this is plotted against sites ranked by post-construction bat casualties, again with the higher bat casualties being higher up the Y scale. So here we found a significant but marginal positive relationship. So essentially we're saying here that sites which perceived high risk were also finding quite high bat casualties. And this is particularly concerning in these sites here. So these are the sites where mitigation was undertaken. You would hope that the sites where mitigation was taken would have quite low bat casualties because this risk had been perceived. However, they were still obtaining high casualty rates. In other words, the mitigation was unsuccessful. So why was the perception of risk not related to casualties? Well, it may be that bats are attracted to turbines, so you could do all the surveys you want beforehand, but you're not going to pick up bats. But as soon as you start constructing wind turbines, you've got bats being attracted to the area. This is because bats may be perceiving the turbine structures as roosting habitats, or they may be foraging habitats around that. Secondly, it might be that environmental impact assessments aren't particularly good at quantifying bat activity or what's going on. It may be that a lot of activity surveys are constructed at the ground level, when actually we should be surveying 50 metres up, using drones or whatever to capture the activity happening at that location. And thirdly, as I said, it may be that mitigation at the minute just isn't being particularly successful at predicting risk or protecting bats from the risk of turbines. So at the minute, a lot of money is being spent on environmental impact assessments, a lot of time, a lot of effort, a lot of money, when we can't actually predict what is going to happen after. So what should we do? Well, we suggest a movement towards post-construction monitoring, where the effort and money that's put into pre-construction is then removed. You put the turbine up, and then you see what happens. So here you could conduct acoustic surveys, you could conduct carcass surveys again, to see what's going on. If no bats are being killed or there's low activity, then you're sorted. No mitigation is required. The turbines are doing a really good thing for renewable energy. However, if bats are being killed as there's high activity, then you do need to consider mitigation. And one of the most obvious forms of this could be curtailment. So you could consider turning off the turbines during peak periods of activity, during the night and the season, or you could be turning off the turbines when you've got high temperature or low wind speeds. And obviously this will cost wind companies a fair bit of money, but because activity mostly happens at low wind speeds, when bats are most active were the periods when actually the turbines aren't generating much energy. So essentially it's quite a margin, it's about 1 or 2% of energy loss the turbine companies would experience. But again, you'd be protecting the bats. So obviously the saying goes that a picture represents 1,000 words. And the Daily Mail, when they reported our research, thought this was quite appropriate for our research. Obviously, they missed the point slightly. But if you would like to read more about the paper, then we published recently in Current Biology, so it's the November edition, and all our research is in there. So just to summarise as I finish, EIAs of wind farm developments do not appear to accurately predict risk to bats. In cases where high risk was correctly identified, the mitigation deployed did not avert the risk. And finally, we do feel that a move towards post-construction mitigation may be a more effective strategy than what's been conducted at the minute. Thank you very much.
Thank you. We have time for one more question. There's one at the back. There's a microphone here.
Thank you. Yeah, this is an extremely important study, and it looks like you've got a load of really good data. I mean, playing devil's advocate, the perceived risk kind of was in the right direction with respect to casualties, and I just wonder, like, do you want to comment on the 17 EIAs that you weren't able to obtain? Like, what stopped you getting hold of those, and that might have helped you resolve the relationship a little bit more powerfully?
Definitely, I think that's a really good question. It's something we really tried hard to obtain. I think it's quite concerning that it's very hard to get hold of this data and standardised data and environmental impact assessments. So there are quite a few councils who said, we've got it, it's in a rusty filing cabinet somewhere, you're welcome to come along and spend a week or so trying to find it. Obviously, we didn't have the resources for that. So I think one of the big lessons from this paper as well is that environmental impact assessments, where people are doing standardised surveys for the government, for local councils, it should be a lot more accessible to see what results. There's not an evidence base out there at the minute to support the consequences that are happening. So yeah, I think definitely it would have helped, but we couldn't get hold of them.
Okay, thank you very much. We have to move on, but thank you. Next, I would introduce Dario Fernandez Bellon, who's from the University College Cork.
Good morning, everyone. I'm going to be talking about indirect effects of wind farms on bird communities. And I had a few background slides prepared, but Paul's already done the job for me. Basically, just to highlight the importance of wind energy with increasing energy demands. Current predictions say that by the year 2050, we'll be relying on wind energy sources for up to 20-25% of our energy. And there's obviously, as Paul highlighted, conservation concerns associated to this, most notably collision risk for bats and birds. However, in recent years, there's been a few reviews of wind energy and their impacts on wildlife. And one of the things they've highlighted is the fact that indirect effects are largely understudied, and where they have been assessed, they show a huge geographical variation, and they tend to be very species-specific. And the thing is, most work has focused usually on single, rare, and endangered species, which is obviously a huge conservation priority, but it leaves us in a situation where we're not quite sure what the impact of these infrastructures and these developments are at a broader community or ecosystem scale. So with all this in mind, we set out to figure out how bird densities varied between areas with and without wind energy development, to try and assess if there was a distance effect from turbines, and to quantify this to actually inform management to say this is the cutoff point where you're affecting bird communities. We also tried to look at indirect effects by looking at land use changes associated with wind farm construction, and ultimately see if these effects were at a community scale or not. And it's worth noting that this is actually encased within a larger project, which is looking at hen harrier interactions with wind farms across the whole of Ireland. So all of the study sites I'm talking about here today are within hen harrier breeding territories, and the importance of these bird species for hen harriers are mainly as prey base. So what we did is we set out to find wind farms for our study. We focused on large wind farms with at least 8 turbines of modern design. So we're talking turbines which are 80 meters high at the hub. And for each wind farm area, we selected a control site. So our control sites were within 12 kilometers of the wind farm area. And they were similar to the wind farm area with regards to elevation range and habitat composition. We then mapped the turbines in each of these wind farms, and we delimited these distance bands around the turbines going up to 1 kilometer away. And within each of these distance bands, we randomly chose points to conduct bird surveys. And what we did then is for each point count in a wind farm site, we selected a matching control point, which was paired for elevation and also for habitat composition. So if you're not familiar with how point count surveys work, you basically go to a predefined point and you spend 5 minutes there counting every bird you see or hear within a radius of 100 meters. So if this was our wind farm point, we then selected a control point which matched it for elevation, but also for habitat composition. And it's important to note that when we chose the control points, we matched them to the habitat existing in the wind farm area prior to construction. And this is mainly to be able to assess that effect of land use changes. So we ended up with 12 wind farms, all of 8 turbines or more, 12 corresponding control sites. We actually did 650 point counts, 500 made it into the final analysis. And this was done over 2 breeding seasons. And just to give you a bit of a context of this, another recent review looking at studies of indirect effects on wildlife highlighted that most studies looked at single species, and that the vast majority looked at single wind farms, and only 7%, which are mainly Pierce-Higgins studies here in the UK, looked at more than 3 wind farms. So we actually had a pretty nice study setup, and as well the advantage that we're looking at a wind farm control design, but also combined with a gradient design, so looking at distance effects from turbines and looking at land use effects. So ultimately what we have is, we have all these point counts, we have a bird density calculated for each of these point counts, and we're trying to see if that's related to wind farm or control areas, whether it's related to distance gradients and environmental variables. So we did a series of models, and we found, surprise, surprise, some of the habitats hold higher densities of passerine birds. Is quite normal. But the interesting thing is wind farm sites had overall lower bird densities than control sites, and distance to turbine had a positive relationship with bird densities. So as you move away from the wind farms, bird densities actually increase. So if we plot this, we have on the However, each of these points is a wind farm and a control point, and it's the actual bird density. So on the y-axis, we have bird densities, and on the x-axis, we have distance to turbine. And what we see is that there is a lower density at wind farms, but this lower density is actually occurring close to the turbines, within 200, 100 meters or so. We actually represent this by the distance bands. We see that the significance is solely within 100 meters of turbines. So what we did then is not look at, break it down and go beyond overall bird densities, and we looked at passerines associated with forest habitat. And we found that this pattern repeated itself. So forest passerines were only in lower densities close to the turbines. And if we actually look at the habitat composition of all of these points and how they vary between wind farm and control areas, we found that there is only 3 habitats which differed between these 2 areas. And they are bare ground, which are mainly tracks and clearings made to hold the wind turbines, clear fell areas, and close canopy. So bare ground was there was more cover of bare ground and more cover of clear fell areas around wind farm sites, and less close canopy. The bare ground is basically, as I say, construction of tracks and clearing of areas, and the clear felling is hugely associated with increasing the wind yield to each specific turbine. And it's quite obvious that this has the potential to impact these passerines that depend on these habitats. If we look at another guild of passerines, if we look at if we actually look at the aerial images, we can see each of those little white lines is a wind turbine, and while you can see that there's tracks crisscrossing the whole wind farm, if we zoom in, you'll see that the vast majority by area of changes to land use occur in close proximity to the turbines. Now moving on to the open country passerines, what we found was that while there was lower densities in wind farm areas across all distances, this was not associated to any specific distance. So this means that this effect was actually at a landscape scale. And initially, when you have an effect at that sort of a scale, the initial conclusion is that the wind farm isn't necessarily related, because you would definitely expect a gradient. So there is the potential for the wind farms to be having a landscape scale effect, but there's also potential with limitations of our study. So while we did incorporate habitat, which isn't usually done, we only looked at habitat within our control points. So it could be that habitat quality differed between between control and wind farm areas. And also the specific quality of habitat. So we said 30% heather in this point count, but we didn't actually assess the quality of that heather. So it is conceivable, and one would actually hope that it is the case that wind farms are actually going in lower value natural areas, and that this is what's resulting in this effect of lower open country bird densities. So I've actually flitted through this really quickly, but to wrap up, what we found is that these indirect effects on passerine communities are specific to each guild. The type of, or which guild will be affected depends on which land uses are affected during wind farm construction, and the scale, so how far away from the turbines we're detecting these effects, will depend on the scale of the construction effects. Also highlights the importance, which is rarely done, unfortunately, in many studies of the effects of the actual construction, not just presence or absence of wind turbines, and also designing our studies so we can actually pick up these effects. And this obviously has huge, wider implications. So within our projects, we're looking at hen harriers. You can use this to either make areas more or less attractive to hen harriers. So if you don't want them going anywhere near turbines, you can actually change the habitats to reduce passerine densities, and also has obviously wider conservation implications. So just to thank everybody who was involved in the fieldwork, the funders, and thank you for your attention.
Great, thank you, Dario. So we have time for a couple of questions. one at the back. Holly will bring you a microphone.
Yes. Hi. Thank you for your talk. Maybe it's too early to assess what is that is actually causing that they crash to the turbines, but maybe the solution may not be in changing the habitat, but changing the turbines. What's your opinion on that?
So from our findings, the turbines themselves aren't actually related to the decrease in passerine densities. There's obviously different bird species. So like, well, hen harriers is not a good example because hen harriers fly low. But as Paul was saying, bats or other species of raptors which do have a collision risk. But for the passerines themselves, the actual turbine, the size of the model, if you could actually just make the turbine appear, that wouldn't necessarily affect them. What we've found is that it's the actual land use that's affecting the turbine, the passerine densities. Don't know if that answers your question or.
Holly, behind you.
Your graphs or your charts had distance from turbine for your control sites. How does that so?
It's a tricky one to get your head around, but basically, if I go back to my maps, so control points obviously don't have a distance to turbine, but since our wind farm sites all have a distance to turbine, then they're paired with the control point. The control points are spread out all over that map, but they're associated to a specific wind farm point, which does have a distance to turbine. So they don't, strictly speaking, have a distance to turbine, but they're linked to a specific distance. And it's important to keep that in mind because there are changes which occur in passerine density with distance to turbine. So most turbines are placed high up on hills or mountains. So as you actually move away from the turbine, you're actually dropping in elevation, and you're going to get an increase in passerine density. And you can actually see that here, that the furthest distance band has more higher densities at both controlled and wind farm sites, and that's why we have to keep that association of distance to turbine.
Sorry, can I have a follow-up?
No, go.
Yeah. So your statistical model includes data from both sites, and therefore the effect of distance from turbine is very conservative then, because obviously there is no such concept for a control site.
No, but it did occur for wind farms. It wasn't in this model, but we had an interaction for wind farm and for site and distance to turbine, and that was also significant. Sorry, I didn't include that in the presentation. And basically, what that tells us is that the distance to turbine factor is significant at wind farm sites, but not at control sites. But yeah, that's a very fair point.
Okay, thank you.
Thank you.
Okay, thanks. We'll leave it there. Thank you very much.
Thanks.
Next on our speaker list today, we have Lucie Bezon, who's from the University of Grenoble.
Hello, everyone. I'm a French PhD student, and I'm in my third year of PhD. The subject of my PhD is biodiversity compensation, and I will explain here some results of my work, and I will start with a bit of context and then focus on one result achieved during the first year of my PhD. So first, biodiversity compensation. It's an approach that aims to preserve biodiversity in the context of development projects. So, for example, the wind farm that we've been talking about. And by compensating the negative residual significant impacts on biodiversity by positive actions that we called offset measures on biodiversity. And so offset measures must be applied in the environmental assessment impacts at the end of the mitigation hierarchy after avoidance, then reductions of impacts. And the overall objective is that compensation, biodiversity compensation, leads to a no-net loss of biodiversity. So one main condition to reach this objective of no-net loss is that ecological equivalence is demonstrated between biodiversity gains with offset measures and biodiversity losses due to impacts. So there's no unanimous precise definition worldwide. So within my PhD work, we stick to the French, the definition given by the French Guidance of the Mitigation Hierarchy, published by the Ministry of Ecology. And so this definition is not really precise too, but what's important is that it takes into account that when assessing equivalence, we must take into account the ecological, spatial, and temporal dimensions. So I'll explain what are those dimensions on this scheme here, where here in the left there's the impacted site, and on the right the compensatory site. And so equivalence dimension, it's basically the measure of biodiversity that we take into account. So it could be, for example, the number of bats killed by in the wind farm, so this measure of biodiversity is used to calculate the initial states of the sites and also the biodiversity losses and gains. And so that brings the questions of what biodiversity should we assess? Is it species, habitats, functions, and what indicators should we use? So the spatial dimension concerns all the landscape context issues, like the connectivities between habitats, for example. And the question is, so what aspects or indicators should we use to assess these insertions of sites into a landscape context? So finally, when assessing ecological equivalence, there's the temporal dimension concerns, on one hand, the interim losses there are after impact and before the implementation of offset measures. And on the other hand, the fact that there is a delay between until the offset measure real effectiveness. And so we have to consider that the ecosystems are dynamic and they are quite a maturity, so we have to consider that. So in France, there's no equivalence assessment method imposed. And they have been developed by the private sectors in case by case, so that leads to difficulties in demonstrating equivalence in practice, and that no-net loss of biodiversity is not always achieved. So there's an increasing need for an objective and reliable method adapted to the French context. So that brings us to the subject of my PhD, which is the development of a methodological framework for assessing ecological equivalence, and with consideration of ecological, spatial, and temporal dimensions. So to answer this large subject, we first analyzed 13 methods that I called here EIAs, and they were developed worldwide. And it's in order to evaluate how equivalence is currently assessed and on which aspect the method diverge or converge. And so we did that by elaborating a grid of criteria about the method's characteristic, like the type of indicator they use or the implementation rapidity, the type of data used also. And we sent a questionnaire to the method experts to answer this question and to fill in the grid. We showed that the methods share a general structure, the same one, but they take into account the different ecological dimension quite differently. Also, the characteristic related to their operationality, scientific basis, and comprehensiveness could be really improved simultaneously. After that led to the determination of requirement specifications based on those results, and so we could elaborate a new methodological framework. So I will there focus on this result. Just to show you the method we analyzed, this selection is rather a representative one than an exhaustive one. There's a lot of other methods, but those ones are quite well used in the field. And So the scheme I will present here about the general method structure, it's in a paper that it's in review currently. So first you have an initial value attributed to the site, to the impacted site, sorry, thanks to a set of indicators. Then then predictions of the final value of what will be of the final value on the site after impact is predicted on the same indicators. And there are compensation units calculated as the values multiplied by the site area. And so losses are represent finally the initial compensation unit minus the final one. So exactly the same steps are followed on the site chosen to implement the offset measures, the necessary offset measures. And what's important is that it's done on the same type of indicators, the same set, so that the comparison between losses and gain can be done. When losses, according to these formulas, when losses and gains are equal, equivalence is reached. So to take into account spatial, temporal, and sometimes also all the uncertainties about the offset measure success, there's multipliers can be used to increase the compensation site area. So within this general framework, the method take into account the equivalence dimensions quite differently, and I will just detail here some of them, some of the differences. So first, about the target biodiversity. The majority of methods target any type of ecosystem, but some target only one type of ecosystem, like wetlands or endemic forests. So the evaluation is very different according to the target biodiversity. Then indicators also can be either chosen by users and also predefined. You have a list and you have to follow exactly the indicators in the method. When spatial dimension is taken into account, which is not always the case, it's either with landscape context indicators, like the connectivities, for example, or by multiplier for increasing the site area. And temporal dimension, so some methods, like, I don't know if you know the habitat evaluation analysis, they allow the predictions of indicator values at every year of impact or offset measures, and that's in order to better take into account the dynamic of the ecosystem. All the thing based on those results, we elaborated on the second year of my PhD the methodological framework, and unfortunately I won't be able to detail it there, but this framework aimed to take into account all the French legislation specificities and to take into account all the ecological dimensions, and also for any type of ecosystems. We also target, the target biodiversity is mainly based on the functionalities of the ecosystems. And so we suggest that the evaluation of biodiversity is done at 2 spatial scales and 3 different levels. And we chose just a necessary set of indicators, a minimum set of indicators. So for further work, we talked about that in the first talk, but we'll try to have reflection on the guidance of the predictions of biodiversity, of the indicator values that we chose after impact and after offset measures, because those, notably between what we expect after an impact, or and more importantly, what we expect after the offset measures. And it's not what happens in practice very often, and that's why there are a lot of uncertainties. And so on this aspect, the return of experiences we can have from previous offset measures can help us better understand how the ecosystems and species respond to offset measures, which can be restoration or creation of new habitats. Thank you for your attention, and I thank all the contributors to this work. Thank you.
Great, thank you. Any questions? I have a question. So this is quite applied. At the moment, it's still quite theoretical. Who's your final target audience? Who, once you've completed this and you've got it all written up, who do you want to use the systems you're developing here?
Yeah, I'm working for the French electricity company, so it's mainly for, in the short term, it's for them. It's for the engineer working on project and implementing the offset measures and developing the project. It's mainly dams, hydroelectric dams. So it's so that they can really know what they impact and if the offset measures they suggest are equivalent to the losses.
And do you sense, is there an interest for this? Is this science that is being developed with a discussion with that potential end user, or is it something you're going to have to convince them later that they need?
Yeah, they need that because it's mandatory in France. Though they have to offset, they have to compensate for the impacts. But if you come and suggest something quite rigorous and objective, but more complicated than what they already do, they are quite resistant at first. But I think with discussion and a lot of time, they will work with some methods like that.
There's one question down the front.
I'm curious how. I can speak loud. It's fine. I'm curious how you measure your y-axis, how you measure impact or compensation. I mean, I can imagine that you could look at the total number of birds, but there'll be different birds. The ones that are being displaced by this dam, you'll do some sort of attempt at compensation someplace else, and there'll be different species preserved there. How do you somehow measure their conservation value?
Okay, so that's a good question, and that's all the complexity of this work. And so the majority of methods just use one indicator because it's easier. So it could be diversity or functional, some aspect of functionality. And so in our methodological framework, we try to concentrate on functional aspects. Functional aspects, but it's not defined in advance. So we just evaluate what's in biodiversity, what kind of biodiversity is on the site, and according to the issues identified, we evaluate the bird or the kind of species that is really impacted. And in terms of if it reproduces, if the site is a reproduction site or a nesting site or things like that. Okay.
I can take one more quick question, and then we'll have to wrap.
Hi. Do you recognise irreplaceable habitats in the scheme that you're working on, or do you try and provide some sort of equivalence for all habitats? You know, in the UK we have a lot of issues with ancient woodland because it takes hundreds or thousands of years to recreate, so we leave it out of the metrics. Do you do the same in what you're trying to do in France?
Yes, absolutely. Yeah, there are when we take into account the temporal dimension, if we show that the offset measures the time until offset measure is effective, so effective has to be defined, but if it's too long and if it's higher than a threshold, it's not, at least the methods say that it's not compensable, but after, people can impact that, but...
Okay, thank you. We have to stop
Thank
there,
you.
I'm afraid, and move on. Thank you very much. Okay, now we're moving on to Chris Wheatley from the University of York. And we're moving on to birds.
Thank you. Yeah, hello everyone, I'm Chris Wheatley. I'm a third year PhD student at the University of York, and I'm going to talk to you today about the second data chapter of my thesis, which is a climate change vulnerability assessment for European bird species. But firstly, what do we mean by vulnerability assessments? Traditionally, we refer to a standardized, objective approach for identifying levels of risk a species faces. The most common famous example of this is probably the IUCN Red List, which has been used to assess nearly 86,000 species globally and identified about 24,000 of those as being threatened and in need of conservation action. However, only about 10% of those species listed as threatened are due to climate change and extreme weather events, which is mismatched with other estimates in the literature which put that figure at being closer to 20 to 50%. So there's a perceived mismatch there. And that's partly because the Red List assessment is based on the symptoms, not the causes of endangerment. So it starts to identify species once we see declines. So climate change vulnerability assessments have been developed to address this issue with the idea that we can assess projected future risk in the same way assign species to a single risk category that's easy for conservation practitioners or policymakers to act upon. With the idea being that we can increase the timescale over the vulnerability assessments act over. It can take up to 10 or more years for conservation action to be implemented once a species is identified as being threatened, and it can take even longer still once that conservation has been implemented to start seeing recoveries. So if we can increase that warning time and identify species at risk earlier, we might be able to implement action sooner and more effectively. So that's the rationale behind doing these assessments. We have done this assessment for European birds using a primarily trend-based climate risk assessment. We use the Thomas et al. 2011 framework, and this is based on 4 separate components. So we score we score a measure of decline based on observed climate-linked declines within a species' existing range, and we also then look at modelled declines within the existing range in the future. Those scores are combined to give you a measure of decline. We then score opportunity and look at how likely is a species to increase by looking at historic recent changes outside their core range, and do the same projecting forward into the future to look at potential expansion of the species in the future. This trend data is then supplemented by scoring with exacerbating factors, so things like, is the species a poor disperser, does it have a mutualism, things like that, anything that could increase risk or decrease risk. And this framework allows us to consider both risk and opportunities under climate change, not just risk, which lots of other approaches do. And we also score each of these components with a measure of confidence. So how good our model fit is, how confident we are the trait is accurate, things like that, which helps to balance the score. So for this, we needed projected future distributions for all our species. So we did some distribution modelling. So we used a Bayesian, hierarchical, spatially explicit, conditional, autoregressive, general additive model, which I'm not going to go into too much detail about because that's a separate talk. But basically, we modelled our birds quite a coarse spatial resolution over the entire Western Palearctic biogeographic region, and then a more finer scaled model over just Europe. And then we used distribution records from the European Breeding Bird Census, which look like this. They're just presence records. And then we used 4 climate variables, which are commonly used in distribution modelling for birds, which were growing degree, days above 5 as a measure of length of growing season, mean temperature of the coldest month as a measure of winter cold, coefficient of variation of the temperature, which is a measure of seasonality, and water availability. We then run the model to model the current distribution for the species and project forward under different climate emission scenarios, with an example for the yellowhammer at the bottom of what that ends up looking like. So we ran these models for all the European species that have distribution records in the EBBC data, which meant we ended up being able to assess 394 of those species. 37 of the species, either the model didn't converge or was a very poor fit, or they were missing other important data, which meant we couldn't assess them, but which left us with the 394 species. We ran the models for 3 different climate emissions scenarios, sort of a low, medium, high set of scenarios, which approximately equal about 1 degree of warming, 1.8 degrees of warming, and 3.8 degrees of warming. Some of the population data that was fed into the assessment was taken from Birds in Europe 2004 publication by BirdLife International, and then the exacerbating factors were collected from a range of sources, from the general literature, from existing European Red List assessments of these species, and from the Handbook of the Birds of the World Alive, amongst lots of other different links and sources. So what does this actually look like? So we feed all this information into the assessment for each species, and that puts the species into one of 6 risk categories. So on the chart here, at the bottom you've got high opportunity in purple through to medium opportunity, limited impact, risks and opportunities, medium risk and high risk categories. So across the 3 different emission scenarios we considered, you can see there is a trend for increasing risk, which you might expect, but perhaps not as strongly as we might have expected. Particularly interesting is actually the high risk category stays fairly, the proportion of species in the high risk category stays fairly consistent across each of the 3 different scenarios, climate scenarios we considered. In total, 91 species were identified as being as high climate risk under at least one of the 3 scenarios, and 61 of those species were consistently high risk under all 3 of the scenarios, suggesting that even in the best case scenario, these species could be of particular conservation concern in the future. We also found that if the low and medium emission scenarios in particular, you've got more than 50% of the species with opportunities or limited impact from climate change in the future, which is slightly different to what other people have found previously, where they focus purely on risk. So it does suggest it's not necessarily all doom and gloom. There is potential opportunities for lots of species in Europe. And as well as this overall category, we can break the score, the combined risk category down into its component parts. So we can look at where the species scores on its risk of decline and its opportunity for expansion in the future. And this could potentially be useful for conservation practitioners looking at can we identify species that we need to focus conservation action within their existing range because they have limited potential future expansion areas, or are species very likely to decline in their range but have high opportunity, so we could focus on being able to facilitate those expansions to make sure we actually make sure they're maximised and species reach all the potential areas they could occupy in the future. We were also interested in looking at how the climate assessment that we've carried out here compares to the existing European Red List assessment for birds. So the figures here, the size of the circle represents the proportion of species within each of those cross-tabulated categories. So the top figure in grey is the unscaled proportion, so it's just the proportion of all the species in the assessment, and in the bottom the circles are scaled within Red List category. So we only have one critically endangered bird in Europe, so you can see that that's why that circle looks massive on the bottom figure, but you can barely see it in the top plot. But one of the interesting things here is you can see up in the top left, in the high risk and medium risk climate categories, we have a big chunk of species that are currently listed as least concern under the European Red List. So this is that potential mismatch we spoke about earlier, and that's actually about 55 species that are currently not listed as threatened under current vulnerability processes that score as high, being as high climate risk. 18 of our species that are threatened in Europe are also highly threatened under climate change, suggesting things may not be looking very good for them, and we may need some real conservation efforts to make sure we don't lose them completely. But again, trying to take some positives, we do have some of our threatened species down at the bottom that have high opportunity under climate change. So there is some hope that if we focus our efforts onto that, we could do some good for those species. We also wanted to try and have a look at various species characteristics to see if there are any broad patterns in climate risk. One of the ones we wanted to have a look at was habitat specialism and see if there was any general trend in that. Again, there was no clear pattern. There were fairly similar proportions of risk across the different habitat specialisms we considered. There's one thing that does stand out is there's limited opportunities for forest specialists in particular compared to the other habitat types, and slightly higher opportunities for wetland and farmland bird species, which is quite interesting. One category that is missing from there that we want to add in is upland species, and they do seem to have a slightly higher proportion of high-risk species in the other categories, but we need to finalise and make sure we've got a really good categorisation for those species to make sure we're pulling out the right ones. We've also looked at other characteristics such as trophic level and range size, various other characteristics like that. But again, there's no particularly strong patterns across any of those. So some take-home messages from this. We have similar levels of risk and opportunity for European birds under climate change, at least for the low and medium emission scenarios that we considered. Interestingly, the species classified as high risk were fairly consistent across all of the different scenarios, suggesting that even under a best case or worst case scenario, some of these species are in trouble under climate change. And there are an additional 55 species not currently of conservation concern in Europe that may become threatened by climate change under a medium emission scenario, and they could become focuses for conservation action in the future. Some further work on this that we're going to be doing. Currently in the process of finishing an assessment of European butterflies using the same methodology, which has been slightly trickier due to lots of smaller range species, but that's nearly ready to go and means we can do some multi-taxa comparisons. We also want to try and do some work on identifying species that may colonise under climate change and see if we are currently underestimating some of the levels of opportunity that we might expect in the future. And in addition to doing this as a species level approach, to do some spatial prioritisation as well going forward. And then some acknowledgements to my case partners at the RSPB and BTO, NERC for funding the project, all the data providers who shared data with us, and the whole organism ecology lab group at York for all their comments and help throughout their PhD so far. Thank you for listening.
We have time for a question or two. Over here.
Hi, Chris. Really interesting talk. Thank you. So I have kind of two questions. Maybe you can decide which one to answer. The cross-tabulation with IUCN risk category, I wonder, you said there wasn't much of an effect, but I wondered if you squint, you could see a slight trend for there to be, for birds that are more threatened under climate change to be more threatened, and I wondered whether you'd even sort of done a simple chi-squared type of thing.
So there is a weak positive relationship between them. So I think I had poor agreement on the slide, which is not necessarily the right choice of words in hindsight. But it's not quite as strong as we would have expected it to be. But it was mainly, it's not a criticism of the red list, it's not saying the red list is wrong, it's more that we're trying to show that these assessments should be done together. Yeah, it's not either or, it should be, this is the current risk, and we know that works very well, but there is also this future risk that we could be considering.
Yeah, so the other thing I found really interesting was the habitat. And it made me think, when you said wetlands that have more opportunities, wetland birds have more opportunities, there's a lot of wetland birds that are actually migrants, and I wondered whether you included migrants in your study.
So the migrants are included, but the models are based only on the breeding range. So one of the things we want to try and incorporate, we're not exactly sure how, is to incorporate wintering distribution, and we know there's lots of evidence for flyways in particular to be disrupted by climate change and sort of stopover habitat being lost. So that might be one area we could try and improve these approaches. We just need to figure out how.
I'm sure that'd be another PhD in it.
Yeah, probably.
Sorry, I'm afraid I'm going to have to stop there just in the interest of time. Chris is still around if you want to grab him at the end, but thank you very much for that. I think this group's doing quite well. I don't know about you, I'm quite chilly in here, but so move around a bit if you need to, but we're bang on time, so thank you speakers for that. And so in that vein, we now have Alka Voskamp, who's from the University of Durham.
Yeah, thank you. Well, so I'm working on birds as well, but I'm looking at like global distributions of birds, in particular how like the distribution and ranges of terrestrial birds are going to change under future climate change. And today I'm going to talk about some work I've been doing at the moment, working towards a global gap analysis for the world's terrestrial birds under climate change. And I'm going to start with a tiny bit of background. I guess everyone in here knows there's ongoing rapid loss of biodiversity. We are in the middle of like an extinction crisis, and extinction levels are estimated to be as high as like 1,000 times as background levels used to be. And with climate change, there's also evidence that species are shifting their distribution towards higher latitudes and towards higher elevations. And with that, it's more important than ever that we have good protected area and good conservation networks. There's been a lot of previous studies that have assessed which species are currently underrepresented in protected area networks. Like protected area networks have been assessed on like global and local scales to see like which species are missing out, which species are well protected. And I think with climate change, it actually adds like another level of difficulty to like get everything protected, since you not only have to look at where are things now, but where are they moving to? Are they maybe moving out of the areas I'm protecting? Well, and to do this, I'm using like a gap analysis. This is like a it has been developed like in the late 80s to like identify conservation gaps and to like understand which species are protected, and to like use basically explicit data, like you have layers of species distributions of conservation areas and of like vegetation, and you overlay them and you identify where you are actually having gaps at the moment and where you are doing well at the moment. And my aims for the study are to assess the current coverage of terrestrial birds by the EIAs. It is to highlight the species that are at threat to lose a high proportion of the coverage in future. And it's also like to highlight those areas in the world where those species are mainly moving out of the conservation networks. And in my talk, I'm going to go briefly over like the methods we're using to do this, and then I'm going to show you like some first results we got out. So we obtained from BirdLife the breeding range data for the world's terrestrial birds, which is about 10,000 species. And we use an ensemble of species distribution models to relate the occurrence of those species to current climate. And we did omit a couple of species, primarily those which are like marine species, some endemics, and some like small defined island species, because those are really hard to like model in relation to climate. They might not even be driven that much by those variables. Nevertheless, we were able to model about 9,000 different birds with our species distribution models. And yeah, the way we did this was we obtained the breeding range polygons from BirdLife International. You can see here, this is like what those range polygons look like. Like on the left is like the rufous-vented chachalacha, and it's like the green is like his current occurrence polygon as the EIA, as BirdLife provides it. And we use those polygons and we grid them up until like a half-degree global resolution. And then we use the current gridded data to like relate it with our species distribution models to like the current climate. And those models we then use to like project to like where future suitable climate could be. So in this picture you see the current distributions again of the rufous-vented chachalaca. And on the right now you see where our models predict suitable climate to be. This is like for one scenario, it's for one GCM scenario, it's for a midway emission pathway, and it's until 2050. These would be the areas where our models say climate is good for this bird. And then in the next step, we also look at like, we not only need like the right climate there, we also need the right habitat. So we look at the primary habitat preference of each bird, and then we clip our future distributions by that climate, by that habitat that is occurring there to see if there's actually at the moment a suitable habitat in these areas. And the final step is that we also take into consideration how far can a bird actually move throughout the century. So what's this natural dispersal distance? Can it get to those areas we predict to be suitable in future? So this is the example again for the rufous vented chachalaca, and he can disperse about 3 kilometers per year, and he has age at first breeding of like 1 year, so that makes like 3 kilometers a year throughout until 2050, which is not very far, maybe about 100 kilometers. And if we clip it by that, you can see on the right, this is what is actually like then left, what we estimate to be suitable in future. And once we have all these data for all the birds, we went and we got the polygons for the global IBA network. The IBAs are the important bird and biodiversity areas defined by BirdLife International. They've been doing that since like the late 70s, and they aim to like identify all the areas in the world that are like vital for the bird populations. And we use those polygons and we intersect them with the future ranges we've predicted with our models to see, to get out numbers to see how many IBAs a bird is in currently and how many IBAs a bird will be in future, and if they are gaining or losing out. Yeah, and we've got like some very first results, like very fresh. And yeah, when we have a first look, there's about, by 2050, if you just look at like the changes in range alone, there's about 679 species under this scenario with, in this time frame that are losing their entire range. Under this prediction, there's about 535 species that lose 75% of their current range, and about 1,100 species that lose more than 50%, but not quite 75% of their range. And if we had a quick look at like how they're distributed along the threat categories at the moment. If you look, for example, at the ones that lose their entire range down there at the left, it's not only the ones that are already classified as like of conservation concern, but it's also like quite a few of like least concern species. As for example, like the picture up the right is a grooved-billed toucanet, and he is reasonably widespread at the moment. He's not like of conservation concern, but he's still predicted to like lose out under those climate scenarios. And if we put this onto like a global map, this is like a richness map by 2050 of those species that are predicted to have like 50% range loss, and we can see, well, it's a lot of the small range species in like the tropical belt and like the Amazon. It's like Western Africa. It's parts of like Southeast Asia as like expected, but it's also like species up in the Palearctic, which are quite wide ranged. And it's the same for like 2070, very similar pattern, Amazon, bit of like Africa, Southeast Asia. And this is the ones that are losing their entire range. They're mainly like smaller range species in the Amazon. And if we look now at the simulated changes in IBA representations until 2050, like how it looks for that, well, yeah, of course, there's 679 species that are kind of supposed to like lose their suitable habitat and climate are not represented. But then there's about 3,184 species that are losing between 20 and 100% of the coverage just in amount of IBAs they're occurring in. There's about 3,718 species that have similar cover, like plus minus 20% of the IBAs they're occurring in at the moment. But there's also like 749 species that are actually gaining coverage, that are like moving into IBA, so that's nice. And there's about 358 species that are not within IBA coverage currently and in future, but many of these are located on like Papua New Guinea, which doesn't actually have any IBAs, so fair point. Well, and if you look at what species are in those different groups, it's like, well, yeah, 60% of those species that are projected to lose IBA coverage are already like endangered or like of conservation concern. But there's also species in there which are fairly large range, which have which live in like the Palearctic and which are like Arctic and boreal breeding species, and they seem to be moving northwards, moving out of those IBAs up there. And if we look at that on like a global map, we can see here again, it's like a lot of species in the Amazon, a lot of species around the Eastern Arc, Southeast Asia, it's like small range species, maybe a species-rich areas, which you maybe expect, but it's also quite distinct like across the Palearctic, like all those like wide-ranging breeding species up there, moving further north, moving out of the IBAs potentially. Well, and to sum this up, of course, there's like substantial variation in species responses to climate change. And well, this is like a first picture looking at one climate scenario, trying to like see some first patterns of what's going on. But nonetheless, we can already highlight some broad types of area where species might be underrepresented in future, which is like, yeah, the tropical belts, the biodiversity hotspots, but it's also like mountainous areas like the Andes and Himalayas, and a lot of like boreal and Arctic regions where the network is not, it's not that many IBAs up there at the moment, and species seem to be moving northwards out of them. And in future, well, there's still a lot of work to be done. I'm still refining the methods. I'm trying to like incorporate the habitats of types of the individual IBAs to see like which IBAs are actually like aimed at certain bird species rather than just counting plain the numbers where they overlap. And I'm working on several climate scenarios. I'm working on several timescales, so there's still a lot of work to be done. But I guess, well, I think it's some interesting first output. Well, and with that, yeah, thanks to everyone, thanks to my supervisors, thanks to my supportive lab group, and thanks to you for listening.
Thank you. We have time for a question or two. At the back. You're giving Holly a good runaround. Yeah.
Sorry, I should have sat at the front. I was just wondering why you looked at IBAs in particular and didn't go on to look at protected areas. Because I think, is it something like 22% of IBAs are actually fully protected? So
it's true, only like about, a bit more than 20% of the IBAs are like specific protected, but I started out with it because, I mean, they are aimed to like, at some point, preserve like the terrestrial bird species. And I'm also, like a next step will also be to like see if I only look at the things which are already like IUCN classified with protection, like what the picture looks like then. So this is like step one. I'm still working.
Question down the front. Well, she's the only one that's warm.
Yeah.
This is really a question for you and the previous speaker to a certain extent. You're looking at what will happen with projected climate change.
Yes.
But for instance, these boreal species presumably also need boreal habitats.
Yes.
And as the climate changes, boreal forests may grow in Arctic areas, currently Arctic areas, but there'll be a lag time there. How do you build that sort of thing into projections?
Well, the thing is, it is quite hard to get land use change data like projections under climate change on a global scale. So I'm still working on like obtaining that information. So for now, I had to go with like the habitat information that is currently available, but I'm trying to like incorporate land use in future. So it's a work in progress. I'm aware that land use changes and like changes in like habitat types are like a very important thing. But yeah, I'm still trying to like get the data and get it incorporated.
Okay, great. Thank you very much. So next we're going to move to Nepal, or near enough. So a little bit of a change in tack. And we have Bowie Den Braba, who's from the University of Sheffield. So we're also very much a Northern English University feel to this morning. Over to you.
All right, hello everybody. My name is Bowie Den Braba. I'm a second-year PhD student at the University of Sheffield, and my BS talk is about social impacts of protected areas in Nepal. Setting aside land for the protection of biodiversity is one of the key conservation strategies. It's estimated that in 2014, roughly 15% of the Earth was covered, and the target is to reach 17% by 2020. Protected areas are not homogeneous entities. The IUCN categorizes them according to their management goal, from strictly protected to multiple use protected areas that allow human use. Recently, there has been some concern about protected areas having negative social impacts. There have been reports about displacement of local people, creating conservation refugees, and protected areas could possibly increase poverty by restricting use and access to the natural resources within. However, there's also benefits. Protected areas also safeguard the ecosystem services, and they might generate additional sources of income, for example, through ecotourism. The question is then, what is the net impact after weighting the costs and the benefits on poverty, extreme poverty, the poorest of the poor, and inequality, the balance of poor versus non-poor? This is not only important because protection should not harm people, but also because inequality is a major cause of conflict, which could then potentially negatively impact biodiversity protection. So my first objective is to assess the protected area impact on poverty, extreme poverty, and inequality. For a policymaker, the average impact is not enough. They also want to know how then protected areas affect poverty. A study from Costa Rica identified ecotourism as the major factor in how protected areas reduce poverty. So that brings me to my second objective, assess how ecotourism drives poverty, using two surrogates for ecotourism because there's not real tourism data, and those surrogates are travel time to protected area entrance and travel time to trekking route. I also varied then the amount of land protected, the duration of protection, and patterns in the landscape, elevation, to bring me to my third objective, assess variation in protected area establishment date, elevation, and the amount of land protected. Nepal provides us with an appropriate case study to study these impacts because it's one of the poorest countries in Asia. 44% of the population lives in poverty. It has an extensive protected area network, as 20% is protected, and nowadays it's praised as a leader in involving local residents in conservation. The aim is to spend 30 to 50% of protected area revenues on community development. Okay, so for the methods, for my first data source, I used a longitudinal national household census data set for the period 2001 to 2011 to construct a multidimensional poverty index, which ranges from 0, not poor, to 1, extremely poor. It's composed of 3 dimensions, and each dimension consists of several indicators. For instance, child mortality is an indicator of health. I then considered a household to be poor if its index was over 0.33, extremely poor over 0.66, and for inequality, I calculated the standard deviation of the poverty index for all the households within a VDC. And a VDC stands for Villagement Development Community. It's similar to a municipality. And here you show a map of all the VDCs in Nepal. Then I acquired a spatial layer of protected areas from the World Database of Protected Areas, and here you see the map of protected areas in Nepal. The question is then, how do you analyze such maps? Because protected areas are not randomly located in a country. They tend to be located in those areas that are already poor because they are far and they are remote. And this also happened in Nepal. You can see there's a lot of protected areas in the Himalayas, a few in the lowlands, the Terai, but there's very few protected areas in the middle hills. And it makes it hard to identify an appropriate control group. That's why I used a method called matching. This method mimics a randomized control trial. It compares a treatment, in this case protected area, versus a control, a non-protected area. And it does so by matching on confounding variables. So you would have for every treatment, you would have a control with similar baseline poverty, similar slope, similar remoteness, etc., etc. And afterwards, you measure the dependent variable, which is poverty, extreme poverty, and inequality at the end of the study period in 2011, to find out what would have happened without protection. Previous research has shown that this method can lead to different results. A study from Costa Rica and Thailand found that without matching, protection would exacerbate poverty. However, after matching, protection would alleviate poverty. Oh, in my case, my results with and without matching were quite similar. So here I present the results with matching. Now, as I said, the average impact is not enough. So I also looked at heterogeneity, which can mask important patterns in the data set, which can show important patterns in the data set. So for instance, if you would have poverty exacerbation at low elevation, poverty alleviation at high elevation, these effects could cancel each other out. So that's why I researched heterogeneity using an interaction term for elevation and my surrogates of ecotourism. And I used a subgroup analysis for the amount of land protected from a little bit, from partially protected to a lot protected. And I varied the protected area establishment dates from those protected areas that were already established at the start of my study period, and those protected areas that were established after the start of my study period. And these are my results for poverty. I see that protected areas established before 2001 consistently reduced poverty in comparison to my control non-protected areas. This result is robust to variations in the amount of land protected. It's not robust to, for those protected areas established after 2001. For extreme poverty, I see a similar pattern. Again, protected areas established before 2001 significantly reduced extreme poverty. And also, again, this is robust to the amount of land protected. However, however, it's not robust for those protected areas established after 2001. For inequality, I see a variation in the amount of variation, but I can say that protected areas do not exacerbate inequality. Then I looked at the heterogeneity of elevation impacts. I see that I see lower inequality at higher elevation, but this was only for those protected areas established after 2001 and only using a 70% threshold. So I conclude that my results are robust to variation in elevation. Results for ecotourism then. I see no effect of ecotourism for poverty nor inequality. I do see that extreme poverty is lower closer to protected area entrance, but again, only valid for those protected areas established after 2001 and only using a 70% threshold. So I conclude that protected area impacts are not directly an effect of ecotourism. So these are my conclusions. The first, protected areas in Nepal on average reduced poverty and extreme poverty. The results from poverty follows previous research from Bolivia, Peru, Thailand, and Costa Rica. And I also researched protected area impacts on extreme poverty and inequality. Second, my results are robust to variations in elevation and the amount of land protected. Not for the duration of protection. There are several explanations. One of them is that some protected areas were established just before 2011, so just before the end of my study period. The third conclusion, I couldn't directly identify ecotourism as a main driver of poverty reductions. However, it could be that because of the way I measured it using my surrogates, this result could be mitigated by the protected area and revenue distribution system that I mentioned in the introduction. And last, I think there's a great need to expand this kind of research to other countries where the context and then also the impacts on poverty could be very different. All right, thank you. Thank you.
Thank you very much. Do we have any questions?
Did you consider? Thanks. Thank you for your talk. Did you consider the degree of decentralization in terms of governance from, say, a decentralized and then a more decentralized, or is that something you would consider for further analysis?
Yeah, well, there's two problems. First of all, in Nepal, it's and also in many other parts of the world, there's popular structure of a strictly protected core protected area, then surrounded by a buffer. So it's very hard to determine what is actually the impact of either. It's one thing to consider definitely in the future.
You've looked at change in the poverty and inequality in these areas. Is there any way to look at how people have moved? Because the sites aren't poor, it's people who are poor. And for instance, are there people displaced from the protected areas? Are there people moving into these areas to take advantage of ecotourism or whatever?
Yeah, that's a very good question. It's hard to explicitly research that. However, we looked at population densities, and they are not different for. You cannot see a decrease in population density from 2001 to 2011. Also, you will be relying on reports, and there have been reports of people getting evicted from protected areas, but this is mainly in the past, before the start of my study period.
I might have missed it at the beginning, but did you also relate to the objectives of, because this is one of the complicated things when we assess protected areas, because some were set up with a commitment at the beginning that communities would benefit, but sometimes it might be implied, but it was never actually an explicit objective of the protected area. Did you find that sometimes difficult to establish? Or is it the case that in Nepal, they are all supposed to be leading to some benefit?
In Nepal, all the protected areas have this rule that 50% is spent on community development. Of course, there are variations also in other ways of management, but this is just a general picture of all the protected areas in Nepal.
Okay, but presumably some were set up more explicitly with that in mind, though. I mean, it might be a general rule, but some, really, the main objective of that protected area might have been a particularly rare population of rhino or something.
Yeah. But these objectives have also changed over the years in Nepal. It's hard, yeah. There's definitely heterogeneity between the protected areas, that's for sure.
Okay, thank you. Okay, now my first plea is don't leave, but unless Marie Longnecker is hiding under a chair, we've got a slight pause. So I say, please don't leave, because those of you who've been to these sorts of conferences before are aware we cannot just bang on with the final presentation, because some people will be coming specifically for that. And I can promise you Bill will not fail to deliver a very rousing presentation to end this great session. So what I would like to do, now in the old days as well, when we used to have sort of, not necessarily the BES, but conferences, you had a collection of themed presentations. We always used to have a bit more of a discussion period at the end. But these days, I think we're all so keen to get so many people along to present that those discussion sessions tend to sort of disappear. So I would just like to put to you all just a bit of a query. So I started off in science, but have since had a career of some 25 odd years as what people sort of call a conservation practitioner, which I don't really like being called, but I've worked for a whole range of different conservation agencies. And one of my main roles has always been trying to turn the science into practice. And one thing I note is there's a lot of really good science going on. And I think in this session this morning, we heard a lot of very good applied research going on. We heard about, just to refresh you, for those of you who weren't here the whole time, we heard a couple of presentations about wind farms and their impacts on species. We heard also different approaches to measuring environmental impacts of dams in the French context. We had 2 presentations around climate change and its effects and impacts on birds. And now we were just hearing a presentation about protected areas and their impacts, the benefits they're bringing to people. Now, it strikes me that all of that conservation science should now lead to some conservation practice or improvements in conservation practice in places where this is relevant. But I think you're all as aware as I am that that's not always as easy as it may seem. And one thing that always frustrates me, being a scientist working in conservation, is all too little or all too infrequently do I see the science being turned into actually changes in how people do conservation. And we heard a little bit this morning, this is actually a bit linked to what we heard this morning about whether people, you know, there is a sort of assumption now people are perhaps listening to big institutions and scientists a bit less. I mean, I've just come out of working for WWF for a long time, and I now work for IUCN, and we certainly feel in that sort of conservation sector that also big institutions are actually probably listened to a bit less than they were a few years ago as well. It's all about people generating their own knowledge and sharing and developing ideas. So if anything, it's more of a challenge than it used to be. So obviously people write up their work, they get their papers out, but I know for a fact, having spent a lot of time working in Africa and also a certain amount in Asia and Latin America, that the scientific papers we produce from the science is not always what your conservation practitioner on the ground needs to be able to do good conservation. It's often using high-tech jargon that is just too much, and again, not belittling the quality and the academic backgrounds of practitioners on the ground, but it's often very much in the space of that particular scientific genre or subject as well. So I was just wondering, given that you're all here and you're interested in conservation science, and we heard some great stuff this morning, if anybody here had ideas about going forward, how we can bridge this gap between the production of the science and then its use. Because I heard a lot of really good ideas and thoughts this morning that I can think of some good applications, but the challenge is then how we make that data available for the people who might use it. So the people who are advocating for protected areas in Nepal, the people that are trying to advocate for green energy, but also trying to minimize the impact of some of that green energy, some of the dams and the wind energy that we're all told is brilliant because it's not carbon and it's not nuclear, but it still actually has an impact on biodiversity. I'd be keen to hear if anybody has any thoughts, reflections, or good examples themselves of where they've seen science converted into practice.
Well, I saw that in my country, in Peru, there are some areas that they are using the natural gas to provide the families with some resource for cooking instead of chopping the forest. And I think that is just the only place that I can mention.
Anybody else got any thoughts? Anybody got some science that they saw or heard about or did themselves that they have seen being taken up? Almost as guidance for our speakers. Most, I think, of the speakers this morning were in the process of producing their PhDs and weren't quite finished. But what sort of guidance can we give these guys for how they can get that stuff adopted?
I'm still at the PhD level myself, but one of the things I've done is partner with an NGO. So I'm working in Nepal actually on snow leopard conservation, and even before I selected my study site, I set up a partnership with the Snow Leopard Conservancy, one of the main snow leopard NGOs. But beyond the individual level, I think the model of the Cambridge Conservation Initiative, where you have a synergy between multidisciplinary departments in the university and then various NGOs around Cambridge, I think that's a model that could be replicated in other universities and their surrounding areas.
I had another point there. Thank you, that was a good point.
In addition to that, it would be worth publishing a more user-friendly version of the research in something like In Practice that CIEM produces. So that might then attract people to go and read the original papers and to look into it in more depth and apply in their professional practice.
At the front, Holly. Thank you. Sorry, we have one microphone and one microphone holder, but she's working well.
Yeah, I agree with you. And in France, we have a lot of journals that are that aim to be read by practitioners. And so I think it's a good way to show the scientific results in a simple way. And also we have this big experimentation in front to develop mitigation banking. And I know that those areas are the study sites of a lot of PhD students, so they can have their own research on the sites that will be used at the bank, and so their results will help develop a good conservation banking. Yeah.
There's one further back.
This is following on from the last 2 points. There is actually there's an initiative set up by Cambridge University called Conservation Evidence, where they provided summaries of papers that have tested interventions. And I know they're trying to really actively promote that to practitioners at the moment, but they obviously need some help with that. And apparently authors, once you've published, you can actually help to upload your evidence onto their website. So in that way, you can help in that way as well.
There was, I think, a hand down here. Was it? No, it's okay. This hand back. Okay. Thank you.
I want to talk a little bit about the other direction, which is that managers can do their management as research, and there's a notion of adaptive management. What often happens is that there's an attempt to find what is likely to be the best management for a particular conservation goal. I'm thinking of in particular example with a rare beetle that was found in a particular site in Britain, and they believed it did best in sort of not just in south-facing edges of birch woods onto moorland, but in particular sort of indented places that are a bit out of the wind. And having decided that was the likely to be the best management for them, they then cut these scallops into the whole southern edge of that woodland. If they could have randomized, cut the woodland into 10 bits, scalloped half of them, and not scallop the other half, so they could find out then whether actually that was the best management or not. Rather than, I realized that part of the issue of conservation biology as a crisis discipline is we can't wait till we have all the right answers. But rather than putting all of our eggs into the basket of our best guess now, trying to find ways to use our management as a way to improve our own understanding of the system.
Yeah, that's sort of following on from that last point. I spent last year on a placement as part of my undergrad degree in Australia, working with Dr. Paul Gibson-Roy, and he's restoring and conserving native grassland in Australia. And as he put it, he would have one foot in industry and the other in academia. So he was using these areas for his research while also engaging politicians and the public in this grassland restoration, and he's got very successful seed production areas to restore these. And he was involving people, the Governor of New South Wales, so I think also effective communication is really important, and he is really, really good at that, and it shows in how successful he's been.
No, I think I heard a couple of three similar points among those comments as well, which is the sense it's quite good right up front if you're doing work that has an application, or you hope it has an application, to get some sort of partnership right up front, either with the relevant industry involved or with a potential NGO that could help make sure that it's used. I also heard one of the challenges, and it's true for conservation too, so frequently, and knowing from experience, there's such a pressure to get the work done. I mean, I've worked in projects in Africa where, with protected areas, where the protected areas staff don't even have any boots, let alone means of communications or transport, or the right training. And the local people are living in relative poverty, totally reliant on the natural resources to survive, where it's very hard to go in and start talking about protocols to monitor the species in the protected area, to monitor the impact of the conservation site, to start thinking about counterfactuals. Do we have a site we can compare this one with, to compare whether it works or not? And it is actually quite a challenge. And I think certainly my experience is that, and I'm chairing this, not giving you my opinions, but I'll just give this one at least. I mean, it is incredibly hard. It's almost a compromise. In the end, real conservation on the ground ends up being a bit of a compromise. There's a lot of very good science behind it, but frequently, when we are just trying to get something done, you just have to do that the best you can, and you can't always set up the sort of best experimental kind of conditions that will really show what has come out of it. That said, and this is a personal bugbear, and I'm talking a bit about this afternoon to plug my own talk at 5 o'clock in this room, but also there is a question of also freeing up the data that moves from scientists to the decision makers and the policy makers. And one of the things that's quite clear, and from our analyses, is that we do need to turn data into more derived products. I heard some good suggestions here. You should, if you've produced something that's applied, thinking of doing not only a paper in a high impact journal that gets you all the brownie points with your supervisor, but also perhaps look at ways of publishing your results in fora that will enable more people to read them, and also use web-based initiatives like conservationevidence.com as well to share those results. But I think increasingly what we see is we need what we call, derived products, but sometimes you need to take the data and see what can you produce out of that in terms of a very specific report or a dashboard or graphics that can then help show people and inform people of your findings and how they might be able to use them. So I would certainly encourage people that are currently doing work that they hope would be applied to reach out as soon as possible to people who you think could use that data. But also think through, if I really want this to be taken up afterwards, what are those other things that I can do to help make my data available in a form that might be of use? Any other thoughts before we move on? Yes, one over here.
We're running a meeting in February called "What's the Point of Conservation Science?" Rather cheeky title, but our...
Who's we? Sorry, who's we?
ERT Conservation and Brighton University. And our take on it is that if you want to make impactful research, ask the practitioners. Get them to drive the agenda. At the moment, everything is driven top-down by academics who want, obviously, to produce interesting stuff, but it's interesting stuff for them. Even the summary of conservation evidence is still a summary of imposed top-down research. Mm-hmm. We want the practitioners to start driving that agenda.
I think you said it a little bit more forcefully than I was prone to do there.
Sorry to be vehement. And if you wish to come to the meeting, you'd be very, very welcome. Come and see me or Rachel.
I would also just point out, though, it's not all one way, because I know from experience, again, that on the conservation side, conservationists are also not as good as they could be at letting people know where they need help and what data would really help them with their job. Sometimes they're not sure themselves what that is, but there could be, and that's why we start hearing about science policy interfaces and things. But it basically means more scientists should be talking to more conservationists and policymakers. They should be in the same room planning things together, not doing things separately, and expecting them to bump and come up with something useful. Great. Well, listen, I really appreciate your patience and your engagement with that. But we're now going to move on to the final presentation. And Rob's going to help me do it so I don't get it wrong and we mess up right at the end. And we are now going to finish with Bowie Den Braber, who's from the University of Sheffield. No. What did I just say? Yes. I'm sorry, I just reintroduced, sorry. I thought I was doing so well. I was so chuffed I filled the 15 minutes so well. This is Bill Cunyon, who's from the University of Leeds. I do apologize.
That's all right. I begin by saying this is in violation of everything we've been talking about, because this is, I do some real conservation sometimes. This is very much a modeling exercise, and hopefully some of it will be of interest. You also may have noticed I've changed the title somewhat, Multitasking for Ecologists. So multitasking, I think we're all familiar with these days, which is that we're all trying to do lots and lots of different things, and we do them all badly. And I would argue that the same issue is really intrinsic to the problem of conservation biology, potentially. Because ultimately, we all know, we've all memorized the fact that the biodiversity comes at multiple sort of organizational scales. From genes to species to communities and ecosystems and all the rest. And all those things are targets of conservation. So we're interested in conserving genetic diversity. We're interested in population viability. We're interested in community species richness. We're interested in ecosystem services. All those are aspects of conservation that we want to maximize. And the real question is, can we do all those things at the same time? It might be that there is basically a best solution. There's the best for all those, in which case it's a win-win and everything, we don't have to worry about these sorts of issues, right? Or that different things are relatively uncorrelated from each other, but you could find a win-win solution that is the best solution for multiple criteria, right? Or life might not be so kind. We may have real trade-off functions where we have to do better at one thing, we have to do worse at something else. And then we have real trade-offs to decide of whether we care more about this one or more about that one, or what combination of them is of interest to us. Now, we might argue, I mean, so these are those criteria again, so genetic diversity, which really actually has a couple different flavors. There's the question of how many different alleles do we preserve and how much heterozygosity do we preserve. There's a question of population viability, community richness, ecosystem service provision. It might be, and we kind of hope it is, that we know that allelic diversity leads to more heterozygosity. We know that both allelic diversity and heterozygosity are linked to population performance, right? We know that obviously if each population is viable, then that means more species. And having greater species richness, we've all accepted as almost an orthodoxy now, that greater biodiversity leads to greater ecosystem function. So maybe, and ultimately ecosystem services. So maybe intrinsically these things are all tied together. In which case, it's a happy situation. We don't need to do all these things. We can only think about any one of them, and we'll do all the rest at the same time. And I think that's the implicit assumption in the literature now. Most papers you see about conservation planning only look at one or another of these things, and they must somehow implicitly assume that all the other ones come with it. But it might not be that way, right? You can certainly imagine that heterozygosity and population viability might be favored by a great big contiguous block of habitat. But on the other hand, allelic diversity and species diversity, which are really in some ways similar, might be favored by having different sorts of environments, which means if we have a limited budget, having less of each of them, right? Which will capture more different types of species, more different types of alleles in a population, and those are very different sorts of design criteria, right? And then we get into ecosystem service provision, certainly for some of them where the natural areas are exporting services to the surrounding landscape. Those you'd want your habitats to be very divided up and interdigitated with the surrounding economically productive landscape. So you could imagine a situation where these things are strongly in competition with each other. And even then, it might be that there are compromises we come up with that do all of them pretty well, even if they're not best for anything. So that's the challenge here. So we assembled various models to model all these things. Right? And I won't go into the details, but basically what we thought of as the best models we could find for them. And we used all of them on a common set of spatial scenarios. So and these were done at a couple of different spatial scales, but essentially they go, I mean, you all know the old SLOS business, so single large or several small. Well, these kind of go from great big patches all the way down to about as subdivided as they could be, and all of that at 10% habitat or 2% habitat. And some of these are real maps of real habitats, so some of them we invented using various algorithms. And so these scenarios differ in the number of patches, in the uniformity of patch size. Some of them are mixtures of big and small patches. Some of them are all patches the same size. Some of them are long, thin patches, or anyhow, lots of different things. And we did all this for different sort of biological scenarios, for things with different dispersal abilities, different population densities, area requirements, and so on. All those things then, that's right. All those things then produce spatial patterns of conservation in all of these landscapes, and we can then compare how these different scenarios do in these different dimensions of conservation. So this is a 5-dimensional graph. Ooh, right? What we have here is is population viability, species richness, ecosystem service export, and then two different variations of genetic diversity as the size and color of those little balls. Right? And this is just one of the various scenarios, but I just kind of want to get your head around just how messy all this is. First of all, the first take-home message of this particular scenario, and that was pretty much true throughout, is that more is better than less. So those are all the 10% landscape scenarios, all these ones down here. And you can see all of them did better on just about everything from all the 2% land solutions. So more is better. If you're looking at genetic diversity, so those two axes over there, essentially you tend to find that was highest on these sorts of networks that were relatively connected. If you look at population viability, which is moving out this way, that tended to be a somewhat more subdivided set of scenarios did best. Right? If you look at species richness, even more subdivided did better. If you look at the export of services to the surrounding landscape, an even more subdivided habitat did better. So it wasn't the happy situation where all these things are favored by the same situations. Now, trying to somehow make sense of all that, we can put it all into an ordination space. So we basically have this 5-dimensional results. We can try to look at how different scenarios work in 2 dimensions. But essentially what you see is, the 2% habitat solutions are over there, the 10% ones are over there, the clumped ones are up there, and the dispersed ones are down here. So that's roughly how this space is laid out. And what you find is that effectively heterozygosity is pushing up that way, right? Allelic richness is down there, metapopulation size is over there, species richness is down there, and pollination services are down there. So it looks like they're, while all of them are pushing that way, all of them are favored by more land, the sort of configuration of that land varies greatly depending on what sort of scenario you're looking for. Which is what I just said. Now, one of the concerns of this, of course, is these are all being produced by different models. So maybe that's just model differences. But it happens that the same model does both of the genetic variables, and it also has a population size piece of it, the MetaConnect model. And it turns out, looking at even within one model, you also get the same situation, that you end up looking for a more connected habitat network. If you're talking about heterozygosity, you need a somewhat less connected habitat, or quite a range of different habitats for allelic richness, and a rather more separated habitat for metapopulation size. Now, we can try to add all those up, and I hasten to add that you could weight them in lots of different ways. This is the rather arbitrary, silly way of just saying, let's just add them up. And what you find is that there are solutions that do pretty well on all 5 criteria, right? So that while these sorts of configurations weren't necessarily the best for any one of them, actually they were pretty close to the best for population size, but for most of the other criteria they weren't the best, but they weren't bad for most of them. And so ultimately you can find compromise solutions that do reasonably well across a wide range of criteria. But if we could only afford 2% cover, then we end up favoring a more clumped criteria. Basically, there's a minimum size below which the reserves can't do anything. So the take-home message from all this is that conservation is complicated. That we do have multiple goals for what we're trying to do with conservation, and those different things tend to push for somewhat different reserve network designs. In general, it seems that more is always better, but there's sort of an order in terms of how much they are advantaged by different configurations. That as we go from genes to populations to species richness to ecosystem services, we tend to favor increasingly more subdivided networks. Nonetheless, that there are sort of intermediate strategies, which I guess I might call multiple medium, if we're going to talk about single larges and whatever. Those sorts of arrangements seem to do pretty well rather than a single large or lots and lots of tiny reserves. And the less land you have, the more clumped you should have it be. So I think that's about all I've got to say. I've acknowledged all the people who contributed to this, and this stuff is all on early online in Journal of Applied Ecology, so you can find out more if you care to. So.
Fantastic. Any questions?
Sorry, I was wondering how much variation each axis explain in your ordination. How much variation?
By definition, axis 1 always explains more, and I'd have to go back and look, but axis 2 explains a lot. I mean, you can certainly see with the different scenarios. There were things that just, in general, those are the 5 different scenarios for various different types of critters. But in general, there are big falls off there, but for some of the criteria, there are fairly steep declines as you move out to more subdivided, or on the other hand, rather steep increases as you go to more subdivided. So there's a fair amount of explanatory power left for the second axis.
Thanks, Bill. That's really interesting. Of course, in reality, most countries now have the protected area networks that they have, and we're sort of driven by a range of different factors, of course, availability of land and the variable costs associated with that over time. I wonder if you would ever advocate using this approach for modifying existing protected area networks such that we might perhaps disinvest from some of the larger areas and invest the capital gained by purchasing areas of land that currently aren't protected to create the multiple medium size from an existing network? Or is that pushing it too far?
I think that's taking these models more seriously than they deserve to be. I certainly wouldn't take these as the ideal ways to plan a conservation strategy. This was largely an intellectual exercise to say we need to think seriously about the different types of conservation that we care about. Yes, I think the answer that a mixture of different sizes will help different things. That a single strategy saying we want all of our land in huge reserves, or conversely we want a little postage-sized temperatures all over the place. Neither one of those is likely to be the right answer. But having big reserves where we need to have them, and small reserves where there's a conservation gain to be made in a particular place, something which is, in terms of the actual planning of particular reserves, I wouldn't take these models very seriously. But I think the issue that we have to make, that we face serious trade-offs between different aspects of conservation, I think that's real.
Okay, one last question at the back.
Thanks. I mean, your implication was that you didn't really like this graph, like when you introduced it, but just sort of taking it as a given, what's really interesting there is when you reduce the percentage of land area protected, the relative performance of the criteria change. And obviously, in reality, protected areas get chipped away at and sort of passed off and things like that. So is what you're basically saying is you can't really rely on particular strategies as a sort of one-size-fits-all thing. Is that what I'm getting from what you're saying? Or? To
a certain extent, I mean, in terms of that particular point, I mean, these are 2% coverage and 10% coverage. We now aiming for 17% coverage. So we're aiming for a world that's over here someplace that's not on the graph anywhere, and that would suggest that in that sort of world, if anything, we'd be more subdivided. But part of well, I called it multiple medium. It's really multiple mixed medium or something like that, because again, some of these best performing scenarios are ones where it's not all big reserves, but it's a combination of big reserves and small reserves and everything in between. And that ends up you end up getting some of the values of small reserves by having some small reserves in the mix.
Okay, thank you very much, everybody. That brings us to the end of this session. I'd like to thank all of our speakers. I think we had a really nice, broad, diverse selection of very interesting talks this afternoon, and I hope you got something from that, and they were all on time, so thank you. My job as chair was very easy. I'd also like to thank Rob for his technical assistance in getting the presentations to work, and Holly for running around like a mad thing with the microphone. This was Conservation Science. In the same room at 3:15 this afternoon is Conservation Practice. So I would strongly encourage you, if you're interested, to come back to that too. But otherwise, thank you very much indeed.